Okay, so let's go through the numbers here, and many of you are aware of this already. All right, so influenza generally infects the upper respiratory tract. It can infect the lungs. Okay, it's a very common disease. 10 to 20% of the American population gets infected each year. All right, so that means in this class there'll be several of you who will get flu virus. All right. 1% of those that are infected will require hospitalization. Right? So out of that 10 to 20% of the American population, 1% of those will require hospitalization. Right? That's a serious case. Of that 1%, about 8% of those will actually die from influenza's complications. Okay? So these numbers, when you combine all these numbers together, what you get is, and this depends on the year, from 3,000 to 49,000 deaths due to influenza. Okay. All right. So this is due to seasonal influenza. So seasonal influenza refers to the sort of garden variety of influenza that happens every year. Okay. When you have serious viruses like H1N1, those numbers could be substantially higher. And that's what we're all worried about. Although luckily H1N1 wasn't one of those. It just turned out to get a lot of people sick. Okay, so something else about influenza that's important to know. This virus can exist in pigs. That's where we get swine flu. It can also exist in ducks or chickens. That's where we get the avian flu. Okay. Now, if you're a virus control person, what's the concern that exists in pigs, ducks, and chickens? Why is that a problem? If you're trying to control the virus, why would that be a problem? Huh?
People eat them.
Okay, we eat them. So that's the problem about spread. What about control? If you want to get rid of, like you want to eradicate the virus. Yeah, kill every single pig, every single duck, every single chicken, every single bird, right? And that's like impossible. Okay. All right. So because there's an animal reservoir, this is the problem with zoonosis. Because there is now I'm losing my thought because I'm thinking about two things at once here. Because there's an animal reservoir. Right, that makes it very, very difficult to control because we can't tell all the animals to come here so that I can vaccinate you, right? So that's an issue. Okay. All right. Also, the other issue is this: influenza viruses continually change over time. Okay? So, in fact, the viruses that we are battling this year are probably different than viruses that we battled in the previous year. Because influenza has this ability to mutate, right? And so you can develop these new forms of influenza. Okay. All right. Any questions about this? All right. So since Doomsday is in the back of our minds right now, right? Remember next week, 21st. Right. We're always thinking about Doomsday scenarios. And actually, there's one scenario which has some real reality to it. Right. We're actually kind of worried about this one, is that there could be a doomsday virus. Right? There could be a virus that causes this global pandemic. Okay? Now, the question is, where would that virus come from? And that's the question that a lot of scientists are trying to figure out. Where would this virus come from? Okay? And one worry is that it could come from it could be a zoonotic, so they think it's going to be a zoonotic disease because, as I mentioned here, we can't control it that well. So it comes from an animal reservoir. And so what kind of animals would it come from? So that's one question. And so if you think about it in this terms, what type of animals will be related to us? Okay, first of all, so if you look at this classification-wise, what kind of animals are we? What do we call ourselves? All right, so beyond primates. So how do we differentiate ourselves from birds or reptiles? We are what? Mammals, yes, we're mammals. Okay, good, okay. Can you remember that? All right, so We're mammals, right? So if you want to think about it that way, we think the next pandemic, the next killer pandemic, one that will totally wipe us out, probably could very well come from mammals, okay? So now the question is, what type of mammal? All right, pig is a good guess. Okay, that's a good one. All right, so the answer is, now I didn't know this either, the answer is it's bats. So the question, that's the reason the question is, why would scientists think it's bats? Like, why not pigs? Or why not other primates? Why is it that they think bats? Yeah, right. Okay, so if you look in terms of diversity, so what percent of species, what percent of mammalian species are bats? Yeah, so it turns out to be 25%. So of all the mammals, right? Like I hardly ever see bats. Right? I see you folks. I see, I think of pigs, right? Or monkeys, chimpanzees. It turns out the most rare species are actually bats, right? Because there's so many bats, right? They're the most abundant mammalian species on our planet, right? Because mammals are close related to us, we're a mammal, and this is where we think the next pandemic will come from, right? The next doomsday pandemic will come from. So on the 22nd, we'll all be here because my calendar doesn't really end. However, we still have bats, right? So that's what's going to get us, okay? All right. So anyway, you may hear about this as being the next pandemic, and you can remember this very day when we first learned about bats, okay? All right. Any questions about that? So. All right. So. Let me go back to influenza and try to explain to you why we're so worried about this. The reason why we're worried about this is because it's been associated with or it's been the cause of some really infamous pandemics. So pandemic is a pandemic. What part of the world is being affected? Everywhere, yes. Okay, so this is like worldwide. Okay. So the most famous one is the one that occurred in 1918 to 1919. Right? It's called the Spanish flu. So epidemiologists often look to this one as their hallmark, their trademark for the ultimate pandemic. Now, you notice we have the terms here. So this is type A, H1N1. Okay, so this is the type of H, this is the type of N. Right, so that's why our recent H1N1 caused some worry, right? Because scientists remember the Spanish flu. This one caused 500,000 deaths in the United States. It caused 40 million deaths worldwide. Right, so the estimates were about 40 million deaths. Okay. What else occurred during 1918 and 1919? Yeah, World War I. Okay, so World War I. So there was a World War going on, right? If you look at the numbers, it turns out that far more people died of influenza than of the actual war. Okay? All right, so, and all these deaths occurred mainly within a 6-month period of time. So, if you go back to their history, like in the United States, you'd find examples of where someone would be fine in the morning, and they start to feel sick, and the next day they are dead. Right, this is just from influenza. Okay. Some other ones. There was one that occurred in the 50s. Right, this was the Asian flu. This caused 70,000 deaths in the United States. This one was identified in China, so that's why it's called the Asian flu. There's one that occurred in the late 60s. I actually had a student who had this one. This was the Hong Kong flu. And so now if you notice, you can see how how we have different H's and different N's. Okay. This caused 34,000 deaths in the United States. And this was found in Hong Kong, right? So some things to note here. First of all, you notice that these two started in Asia. Like one's in China, one's in Hong Kong, right? And in fact, you often find that when you look at what's in your vaccine, your flu vaccine, you'll find that some of the viruses actually, many of the viruses actually come from somewhere in China. So why is it? Why is it that it would be in Asia? You know, why don't you find it in, you know, like in Texas, more often in Texas or Kansas?
Population.
Yes, population, exactly. Okay, all right. So I think as I say that, I think this year's has like something from Wisconsin, but usually you find them from more populous areas. Okay, so that's why you often see Asia as the source. Okay, how do they get from? Remember, China's far away. How do they get from there to here? Yeah, so it's because of transportation. That's why they can spread.
Oh, I was going to ask, on the final, do you want us to know like all the dates and the numbers of deaths?
No, you want to know the dates. No, you want to know that. You should know what H means and what N means, so I will ask you about that. Okay? But, yeah, I want to ask you for the specifics of these. I may ask you about the Spanish flu, H1N1, all right? Just because that one gets mentioned a lot in terms of ongoing the next pandemic, right? So any questions about this?
Are the B types less virulent or less likely to cross species? I noticed they're all ladies.
Yeah, so the bees, I think probably by the nature of the virus, type of virus, they're just less pathogenic. Right? Okay. So, French, any questions about this? Yes.
Yeah, how many H proteins have been identified and how many N?
Yeah, so we're looking in terms of like 10 to 15 of each.
Okay, so you could have all this combination.
Yeah, and also, even though this is H1, this is how we identify it by, let's say, using antibodies. There are still differences in H1 that antibodies don't detect that make it different from this one. So now that we can determine the exact genetic structure, we know that this is slightly different. This H1, the one that affected us in 2009, is slightly different than the one that infected the world in 1918, 1919. Any questions about this? Okay, so let me give you two other concepts. This is a little bit meatier, or a little bit more complex, but it's very often used clinically. It's often used in the medical field to characterize how influenza and other diseases change, other pathogens change. So there's two terms. One is called antigenic shift,